Hmm. How you guys doing? I'm wearing a white shirt, so I'll have to turn off my virtual background for today. Okay, just sent out an announcement. I have not uploaded the video yet from the previous class, but I will. As soon as I'm done with this class and the next class, I'll get that done. It was a long edit. Now, if you looked at the announcement or if you're reading it right now, basically it says this, where I'm going to show you guys how to, and we're going to try this. It may not work for everybody, or you might have to do a couple of fancy things to make it work. Normally, I have the students here using the EI lab, accessing workstations that are here in the EI lab. Can you guys all hear me okay, by the way? I guess I should always ask that in the beginning. Okay, good.
Yes, we can.
Thank you, thank you. So usually I have students come into the EI lab and we have 15 workstations in here. I have you guys sit down to the workstations in the EI lab, log into your Windows virtual machine for the first time because it's local. And then at that point, I have you install some remote viewing software like Chrome Remote Desktop so that you can then go home or go somewhere else and access the EI lab. Since we're not able to do that, we might want to use the other method of remotely accessing machines that are behind a firewall. And that's what the issue is here. All of the workstations and most of the servers in the world actually are behind network firewalls. That means that when you go to a certain website or a certain web page like www.uh.edu, excuse me, you're not probably talking to the actual server, you're talking to a firewall. And that's, and I'm trying to get you guys to understand that, and that's why I had you do that first assignment where you looked up what your local IP address was, which is probably something like 192.168.0. something, but then your official public IP that the world thinks you're at is some public number that you got by either going to a website like whatismyip.com or ipchicken.com or ipmonkey.com. So that's true for the EI Lab network as well. I have a firewall, which is a device which is connected with one network cable to the outside world, to the public network. And then it's got another port on it, another cable connecting to the inside network. And it has a separate set of IP addresses. Because of that, there's only two ways to access anything behind the firewall. Everything in the EI Lab is behind that firewall. There's actually three ways, but one of the three ways is there's a wireless access point here in the EI Lab, which means you could access, and it's behind the firewall, you could access that, except you'd have to be within range of this wireless access point, which is pretty much just right around the College of Business. So that doesn't really do you guys any good unless you want to sit out on the outside of the building. So two ways we can accomplish basically punching a hole through a firewall. And one of them is by initially setting up some sort of remote viewing software on the desktop or the workstation or the server that you're going to use. And that's something like, let me share my screen here real quick. That would be something like TeamViewer or Chrome Remote Desktop. So I'm going to just point out a couple of those first, and we may experiment around with using those, but here's TeamViewer. Download for free. So you can download this piece of software, and TeamViewer is both a client and a server piece of software. So you would download this program, this TeamViewer program, then you would set it up to automatically run when you boot it up, and it presents you a 12-digit number. You're supposed to memorize that number, and then you can go to another computer, set up TeamViewer, and then enter that 12-digit number and an optional PIN or password, and remotely view this screen. Another popular way to remote view computers is to use the Chrome Remote Desktop, which is what I use all the time. So as you can see, you guys see my list here of these remote computers. I've got several computers that I access remotely using the Chrome Remote Desktop. But like I said, in order to make that work, you initially already have to have real access to it, like you're right in front of it. Or you had to access it through Windows Terminal Services or some other way. Or it already has to have software built on it, installed on it, like the TeamViewer, and then you have to be given the credentials. So all of these computers are located in different locations behind different firewalls. And that ultimately, in my opinion, this is not the opinion shared by all network managers, but in my opinion, this is the best way to do it, because this does not involve, it puts security aside for a minute, this does not involve the need to have to worry about routing. And I'll talk about routing in a minute and why this may be an issue to use VPN, which is the other way to do this instead. Let me pull up my chat window here. So using remote viewing software is not the same thing as using VPN. Oh, there it is. Chat. So I'm going to show you how to use VPN, and let's see if we can get that working. Like I said, it might not work for a technical reason for you, but hopefully it will. So here's what I did. Right now I am on my laptop here talking to you, but I am not on the EI Lab network. I'm actually talking. I'm going to open my network and sharing center here. Let me show you what I'm doing. Now, I am talking on the U of H's public network, not internal to the EI Lab. So I can't access anything in the EI Lab directly, either via a web page or via network sharing. You know, I can't open up a Windows browser window like this and look on network and try to find anything. It's not going to find anything. So one way to connect your network, whatever network you're on at the time, your local network, and it might just be your laptop sitting at Starbucks or your laptop on a wireless network somewhere else, to connect your network, or your computer, I should say, not your network, to connect your computer to a local network, we want to use VPN. So has everybody heard of VPN? You need to make sure you know, and we're getting a little bit ahead because we learn about VPN later on in the class, but make sure you know what VPN is. Just Google for VPN Wiki. See if I can find it. A simple explanation of what VPN is. A virtual private network, or VPN protocol, is a set of technologies which are used to link computers, or more specifically computer networks. That's what we're trying to do. Not just connect two computers together, but connect either your computer with an entire LAN. I'm talking about a local area network, as if your computer's sitting on it when it's actually over the internet somewhere, or connecting two LANs together that are nowhere close to each other. So there's two broad groups of VPN. So if this is our main office here, this is the internet, and we wanted to connect another regional office, we could use a router or a gateway device that has VPN capability built into it, and it would log into a router or a gateway here that also has VPN capability built into it. They have to be set up the same, with the same kind of VPN protocols and encryption and passwords. They establish automatically a link with each other if you tell them to do that, and they will merge those two networks together, sort of. The two networks will still stay separate in terms of their IP addresses. And actually, you can blend them together, but usually we keep them separate so that you can talk to any machines back here behind the firewall, behind the gateway, without having to use any special software. You can, like I said, just use a web browser. The other way to do it is on your laptop, you run a piece of VPN software that would attach only your laptop to that network. We call that Road Warrior VPN. That's the generic term for it. This is site-to-site VPN, or STS, or site-to-site, or point-to-point. Sometimes you hear it called PTP. Point-to-point VPN, or Road Warrior VPN. So I'm going to try to show you today, and you can try this to see if it works today. I don't have the Windows 10 virtual machine set up yet. I've got Windows 7 virtual machine set up, but I'd rather go ahead and just try to get everybody working on a Windows 10 virtual machine, since Windows 7 has kind of gone away now, not supported anymore. So first of all, I have already set up my local gateway. I'm just going to show you, I'm going to show you the front end of that just so that you can see what it looks like. I think I can get to it from here. So this is I know that looks like a private IP, but that's 192.138, not 192.168. And maybe before I even go any further, I should probably mention and have you understand the difference between a public and a private IP. There are three ranges of IP addresses that are intended to only be internal. And then all the other IP addresses are external. So if we type in internal IP ranges, let's see what we find. Here they are right here. So anything that's 192.168.anything.anything. Anytime you see a 0 in an IP address, that's anything from 0 to 255. So 192.168, anything.anything, all the way through 255 is yours to use however you want internally on your local network. You could hard code different computers in your network with these different IP addresses as long as they were unique. Usually you don't do that. Usually you rely on the gateway device, which is attached to your network, to hand out these addresses for you so you don't have to do the work. Another range that's used, and we use this on the U of H wireless. So for example, right now, my IP address of my local computer here, here's my wireless connection on the UH wireless network. If I were to click on details, I've got 172.17.227.164. That falls within this range. That's also another internal range. It's not a real IP address. It's used for internal only. And then finally, the third, which is an example of Class A addresses, is 10.0.0.0 through 10.255.255.255. So out of these three ranges, I guarantee you everybody sitting on the Zoom meeting right now has some IP address within these three ranges. If you don't, if you go check your IP settings, your local IP settings through this window here, and it says something other than that, that means that you're actually living dangerously. You're actually in front of a firewall. That means your laptop, your PC, their workstation that you're using is publicly addressable and publicly accessible by anything else on the internet. In other words, it's kind of like having a telephone with a real telephone number on it. Everybody has a cell phone in their pocket, and most of you have a cell phone that has a real telephone number on it. So I could call you. Not usually a problem, or maybe sometimes it is. Or do a lot of you guys get spam telephone calls on your cell phone still? There was a point to where I was getting maybe 10 or 12 a day. The cell phone companies are trying to crack down on that. Well, imagine computer networks and computer programs doing the same thing to try to hack into web servers and client computers, but on the order of 1,000 times per minute. That's kind of like what was going on. So if you are surfing the net with a public IP, that's bad. Get off that network. You're probably not being protected. Okay, so back to this, that 192.138. I know that looks like a public IP, a private IP address, but it's public. I'm going to show you something else here. Write this down or pay attention to this. I'm going to show you some links to some very useful tools that all network managers should know. Let's say you want to know where that IP address is. What country is it located in? Who it belongs to. You take an IP, this is copy that IP, and there's several sites, but my favorite is the original, which is ARIN.net. That stands for the American Registry of Internet Names and Numbers. They used to be the exclusive registrar of all IP addresses. I'm not talking about domain names. I'm talking about IP addresses. So watch this. I'm going to take that IP address and I'm going to paste it in the top here and search. I'm going to click search and let's see what the results are. This tells me that, and you can do this with your IP address. So you can go to whatismyip.com. Whatever that IP address is, copy and paste it off that web page. Go to ARIN.net and plug it into the search box up here and see what it tells you. I bet for most of you it's going to say something like Comcast or Xfinity or AT&T or InTouch or Windstream, some local carrier. So this says this is a net block called the 192.138.194 net block. That's a Class C. Here's the network range. Here's the name of it, UHRIX. Sounds kind of familiar, doesn't it? It was registered way, way back in 1992. So it's been around a long time. This is actually a Class C subnet range, which was assigned to the RICS department of the Bauer College of Business so that we could do whatever we want with it. Univer 239, so it was the 239th, I can tell by these numbers, it was the 239th autonomous system number range allocated. Now you might wonder why that says 4213 Elgin Boulevard. It's Elgin, not Elgin, by the way. And that's because that's where all of our internet connections actually come into the campus. That's that's the College of Computing Science. It's actually next to Channel 8. If you guys know where that is, there's a building over there with no windows in it. And it's kind of hard to get into that building. That's where all the internet is. If you scroll down further, you can find additional information like the telephone number and the email address. These are required by law, required by the organization, I should say, to be here. So there has to be something valid there. This is really helpful for people when they're getting hacked or when network managers are trying to figure out, hey, I've got somebody trying to access my system. The log says they're coming in from 102.33.15. whatever. What is that? That number doesn't sound familiar to me. It's not one of mine. So I'll come over here to ARIN and I will Google for that, or ARIN for that, search for that, I should say. And it'll tell me who owns that net block. Most of the time when it's hackers, when I've got a bunch of failed attempts, it's always coming from the RIPE network, RIPE, which is, they are basically the registrar for Europe. They're located in Amsterdam. And yeah, they're usually, if it's coming from over there, trying to access my servers, it's probably not students, it's probably hackers. So anyway, remember that, ARIN.net, very good website to use. So back to this 192.138, that tells me that's a public IP. Now, if you were to go Google by it, not ARIN, but I'm going to search for 10.0.0.1. Let's see what that says. There it is, 10.0.0.1 for 255. It literally says right here, these addresses are used by independently operated networks. In other words, they are reserved for internal use only. So you won't see, you'll see the IANA, which is the people that originally created. That's the Internet Association. Google and click them, see who they are. So that's not that tells you that's not a public IP address. Okay. So here's my Sonic wall. I'm going to log into it, admin disk 2015. Now this is a rather complicated firewall. Some of you have firewalls at home which are much more simple. You basically have two connections, a WAN connection, which stands for wide area network, and a LAN connection, local area network. Oh, I must be logged into it somewhere else. Okay, well, that's all right. I don't need to log into that. I was just basically trying to show you that we've got a firewall here that's connected to the internal network and the external network. The internal network range being, let me open a WordPad document. So my internal network range in the EI lab that I'm using is 192.168. 8.1. everything. I'm going to denote that by 0. I'm going to put a /24 after that. And we'll talk about what that /24 means a lot later. So that's what my internal range is, where all the servers are, where the workstations are. So one of the first numbers that you need to know is that there's a domain controller, which is a Windows server sitting in the EI lab. Its IP address is 192.168.1.31. Oh, can't type today. That's what all the machines in the EI lab authenticate from. In other words, when you sit down to one of the workstations in here and it says, please enter your username and password, it's looking at that computer and saying, hey, do you have the list of authorized users? Yes, I do. And that was all predefined when we built these internal workstations. We joined them to a domain. Now, usually we don't use an IP address to refer to a Windows domain controller. We use its domain name, its internal Windows domain name, but you're going to need to know the IP address since you're not internal to the network, at least initially. You're not internal to the LAN. So keep that in mind. And this is in the announcements too, that 192.168.1.31. And then, as I mentioned before, the firewall, which has VPN turned on. You can't do this with just any firewall, any gateway device. You have to have already programmed in the VPN settings, which I did already last night. Its IP address is 192.138.194.45. Okay, so right now I'm going to first, just as a proof, I'm going to try to ping that IP address. It should not work. If it works, then, something weird's going on, but it should not work. .192.168.1.31. It's not reachable, okay? It's timing out. If it was working, you would see once per second a new line there with some information. If you've never heard of the ping command, learn the ping command. It's very useful to use. Let me change it. Let me blow this window up a little bit bigger. Oh, fine. Let me make this a little bit bigger for you, or bigger for me, I should say. I'm having trouble seeing. Okay. So here's a couple of other handy commands you need to know. So I've already mentioned ping. So let's put that one down. And it's very simple. And ping exists on every computer, Mac, even your cell phones. If you don't have ping, you can go download ping from the Google Play Store, the Apple iTunes Store. Download a ping command. Ping, and then either the name of a server like google.com or an IP address. So if you know an IP address, you can type that in. But I'm just going to say, I want to ping. Let's try pinging ESPN.com. Okay, cool. ESPN.com is up. By the way, if you ever try to ping ESPN.com and you know you're on the internet and it doesn't ping, that means it's probably the end of the world. ESPN is one of the most, I'm not a sports guy, but ESPN is one of the most used networks in America because it's also owned by Disney and ABC, and they're all located in Orlando, Florida. So some other things that you can do, let's use the route command. Or actually, first of all, everybody hopefully is familiar with the ipconfig command. I think this is in my little assignment as to what you're supposed to do. If you type in ipconfig, and sometimes that's too much to show on the screen. So you can scroll back. ipconfig will give you information about the network controller in your computer, and the things that you're probably interested in are IPv4 address right there. So that's your local address. That's your subnet mask. That's your gateway. That's the IP address of a computer or a router. The gateway that you're attached to, that's its local internal address. So ipconfig, very helpful command. Okay, got that? One sec for me. Okay. Another helpful command, and this is ubiquitous between Windows XP, Windows 7, Windows 10, Mac OS. All you got to do is figure out how to get out here to a command prompt, and that's different on different computers. But usually, you can just click the little flag down there, type in CMD route. Type in the route command. The route command will tell you what possible routes that data has to get out of your computer and out of your network. There's different things you can type after route, but I'm going to use the route space print option. And again, that might be kind of big. So let's just look at this really quickly. And I'm kind of throwing this at you earlier than I normally throw it at you in the class, but I think it's important to go ahead and understand this right up front here, because out of necessity, everybody's communicating remotely. And you're going to have issues possibly when you're trying to set up your VPN or trying to set up remote viewing that might be related to routing. So it's going to help you to know this. So if you type in route space print, again, it might be a little different on Mac OS, but it's going to be something similar to this. This is giving me my local routing table. Can you guys all see this okay? Okay, so here's IPv4. I'm not worried about IP version 6. That's down here. We'll talk about IP version 6 later on in the class. I don't like IP version 6. The numbers are too hard. Okay, so destination. Here's the destination column. First of all, I want you to locate in the column your IP address. There's going to be one line with your IP address in it. And this happens to be right there. I did the ipconfig earlier, and it told me that my IP address was 172.17.227.164. Whoops, that's the ESPN. I'll ping that. Route print. Where's route print? I don't like to type stuff over again. I just like to hit the up and down arrow. I hope you guys know you can do that. Up and down arrow gets you scrolling through the previous command. So this line right here says destination, meaning if I want to send internet traffic or web traffic to my computer, to my own computer, to my IP address with this net mask of all 255s, and I'll describe in a later class what the net mask is. I send it to the very same interface. In other words, this is called your loopback address. So actually, this is your local address. That equals that in this case. There's actually another thing up here called loopback address. Every computer, even one that's not on a network, has 127.0.0.1. You get that IP address automatically. That's actually called a loopback address. That's so that if you're running an application on your computer, which is a service like a server, and then you run a client program like a web browser. That client program can talk to that server program within your computer. It's kind of like the left half of your brain talking to the right half of your brain, but you have to use special coding to do it. Okay, so yeah, Mac has terminal. That's equivalent to the command line of the CLI, the command line interface. And again, you can always Google for that. How do I open a command line on a Mac or Mac OS? There's lots of good Googling, lots of good information on that. So that line up at the top here, not the 127.0.0.0, but the 127.0.0.1, that line is essentially the same thing as that. If you're not connected to a network, you don't see this line. You only see these first few lines. You don't see all this other stuff. So let's look at a couple of other things to see what we can figure out. This very first line, where it's all zeros. What did I say about zeros in an IP address? That means everything. Wildcard. Pretend it's asterisks, you know, star dot star kind of thing. So if you ever see a destination of all zeros, meaning how do I get to the world? How do I get to the internet? I use this gateway right here, 172.17.255.254. That's your gateway address. If you go back to the ipconfig command, that will match what you see right here, default gateway. Now, for most of you, that's going to be something.something.something.1, not .254. It's rare that it'll be something other than .1, and that's only because 99% of the time when you go buy a gateway device off the shelf, a Netgear or an Asus, or you're renting one from Comcast or Xfinity, they program it in for you. So it's probably 10.1.10.1 or 192.168.0.1. Okay, so my local computer IP address is that. What I don't have in here is any reference to any 192.168.1 dot anything. You don't see that anywhere. So that means, you know, I see something close. I see 192.168.56 dot something. And that's only because I have another VPN running to that network range. But I don't see 192.168.1 dot anything. So I can't talk to that network because it's not public, it's not routable. I can't send my traffic through this route, the default route up here, because this gateway won't forward internal traffic like that. So I need to somehow get into this table 192.168.1 dot stuff, okay? Now here's where it becomes a problem. Some of you already are operating on the 192.168.1 network, so this might be a problem to set up this VPN for you, in which case I'm gonna have to figure out something else for you. So this is how you do this on Windows. Again, I'm not sure how to do this on a Mac, but I know how to do it on Windows. I'm going to go to my networking. I'm going to go to my network and sharing center. I just typed in the word NET under the flag. I see here, set up a new connection. I'm going to click on that, set up a new connection. Now, I've already got one set up. So I'll just edit the one that I've got set up, or actually I can set up another one. You want to connect to a workplace. Set up a dial-up or VPN connection. Now, some of you have used VPN before, and you've possibly used software that you downloaded, an application like Cisco AnyConnect, or OpenVPN, or Global VPN, or Ola VPN. It's a bunch of apps you can download, but Microsoft has VPN capability built into it. Let's just use that. So I'm going to click connect to a workplace. Next. These are the two I've already set up. This is the one I've set up already, so I'll show it to you in a minute. So I'm going to say no. I'm going to create I'm going to create a new connection. So if you do have any, create a new connection. Next. Use my internet VPN connection. We don't want to do dial-up, so do that. Internet address. This is where you need to know, and again, this was in the announcements, and then I also typed it in that WordPad document here. We need to know not that address, we need to know the firewall address, 192.138.194.45, or the name, if it has a DNS name, which I believe it does. I believe it's eilab.bower.uh.edu. In fact, let me try pinging that. eilab.bower.uh.edu. Let's see if anything comes up. Did not come up. Okay, so that's possible that whoever manages the uh.edu or the boweruh.edu domain has not set up DNS for that IP address, which is fine. That's okay. We'll just use an IP address. 192.138.194.45. Destination name, call it whatever you want. I recommend calling it something descriptive like eilab VPN. Okay, leave remember my credentials checked. You don't need to check that, so just leave the upper and lower box unchecked. Click create. So now it's created that connection. How do I use that connection? I'm going to go over here to, there's a couple ways to do it, but I'm going to go here to change adapter settings because you've now created a new adapter, a new network adapter. It's a virtual adapter. Change adapter settings. Now, most of you are going to have one, maybe two. If you do this in your Windows computer or your Mac computer, I've got several because I've got a Bluetooth. I've got Bluetooth in this laptop and it's on. I've already set up eilab a few times. I've got an Ethernet port on this computer. It says it's unplugged because I'm not using Ethernet. I've got a local area. These are kind of the same thing, by the way, Ethernet and LAN. And then I've got a wireless network connection. This is the only one that's actually active, actually running. It says I'm connected to something called Wireless 3, and it's running. So that's my active connection. The one I just set up, what did I call it? It's right here. Let's look at the one that I initially set up yesterday just to see what the parameters are. So I'm going to go to its properties. There's the IP address I typed in. You're going to click on options. Look under that. Remember my credentials. You can change that if you want, and I recommend that you do that. You don't want your computer always connected through the VPN that you're going to set up. So change it so that it will automatically log you off after a certain amount of time of not using it. Maybe like, I don't know, 30 minutes, okay? Let's go to security. This is where it gets a little hairy when you're setting up VPN. There's many different kinds of VPN protocols. We are using L2TP, Layer 2 Tunneling Protocol, with something called IPsec, IP security, okay? So you're going to choose that. Let me go to this one. That's the new one I set up. Let's go to it. Let's see what the defaults are, and we'll go with the defaults. Yeah, it's on automatic. So let me show you this because that's what you're saying. It's on automatic by default. I want you to change that. It probably would work if you left it on automatic, but it takes much longer to connect because it's going through all these other protocols that are not enabled before it finally says, okay, I'll try L2TP, see if that works. So just go ahead and change it to that now. Then click on Advanced Settings, and we're going to change that to using a pre-shared key. Now, normally we don't use a pre-shared key for end-user laptops, but this is the only way I could really get this working for everybody quickly and easily. The pre-shared key, which I set up already in the firewall here, is disk 2020. So remember that. And that's again, that's in the announcements. So the what we call the PSK, or the pre-shared keys, DISC 2020. Okay, I change that every semester. Okay, data encryption, you can make it optional, or you can require it, or you can make it maximum. Let's see what I did over on this one. Edit it. Because I can't remember what I set it to yesterday. I think I probably set to require encryption, but not use the maximum level. Oh, okay, I made it optional. Let's just leave that on optional, and that's because my server is actually telling your computer, you do need to use encryption, and it's automatically negotiated. So just leave that on optional. We don't need to do anything else with this. Networking. All of those are checked. Leave all of those checked. Sharing, don't worry about that. You can click that if you want. And what that will do is that will end up making your computer a potential router to be used for any other computers on the local network. Like I said, usually you don't want or don't need to do that. So let's go back to this one here, properties. Okay, so IP address, remember my credentials. I'll make it hang up after 30 minutes of non-use. Going to change that to the L2TP tunneling protocol. Use the pre-shared key of DISC 2020. Pretty easy so far, right? Don't need to change anything here. Everything's checked there. You don't have to check all these things. In fact, you can turn IP version 6 off if you don't need it or want it, but let's just leave it there. You can change the properties here if you want. Do you want to obtain an IP address automatically? In other words, DHCP? Yes, you do, so leave that alone. Let's click OK. So now let's connect. I'm right here already. I went to the network. So you can connect from right here. I can just right click and click connect. Bring up this window. Here's the one I just built. That's the one that I was testing with yesterday. So I'm going to click connect. It's asking me for a username and a password and possibly a domain. Let me go to advanced options here. I can go ahead and set a domain there in the settings, or I can just do it as I'm going. So username. Your username is going to be your student ID. So I have a sample one set up of 1, 2, 3, 4, 5, 6, 7. The password. I'm going to email everybody a password a little bit later. In an email, I'll make it relatively generic. I already have a password set up for this one. And then domain. Now, a domain is not as critical, but if you wanted the domain to go in, you could type in 0000 at eilab.bauer.uh.edu, but it's not critical for purposes of authenticating to the VPN. So I'm going to click OK. Oh, it's complaining. Oh, wait a minute. I think I know what's going on. I think we don't need that, so I'm just going to click cancel on it. I'll check it in just a minute by going to this one, which I know works. Oh, I see. It didn't. Let me edit it here. Okay, so I right-clicked, went to the settings, I'm advanced, and then I'm going to click edit here. should have worked unless I changed my password and I forgot what it was. Something's not quite working. It was working last night. I've not done something right, I believe. So I'm going to send you instructions in the email. And it might be that I'm already VPN'd in. You can only VPN in. You doing it this way, the way I have it set up, you can only VPN in one time from one computer with that unique username and password. There it goes. I think what it had to do is it had to kick off the other one. Since both of those are connected, they're not really both connected. Only one of them's connected. I'll disconnect that. Yeah, they're duplicates of each other. So now let's go back here. And let me type in route print again, and let's see what changed, if anything. I don't see 192.168.1. anything in here, but that's okay because I now have another link. There it is right there, 192.168.9. I programmed into the router, and this should not interfere with anybody else's network. I programmed in a network range of 192.168.9. everything. So you have now been given a new IP address to communicate specifically over a VPN connection. Let's test it. Let's ping 192.168.1.31, not .9, but .1. Let's see if it's accessible. It is, it's pingable. So what's going on is you're trying to communicate with this IP address. It knows that there's a route through 192.168.9, so it's sending it through there. Here's another command you can use, TRACERT, trace route. That's what that's short for. Trace route 192.168.1.31. That's going to tell me my path, or how the data is getting out of my computer to the other computer. It literally took just one hop. So that means that I'm now connected to the same network through the VPN as the disk network. In other words, I'm only one hop away. Let's trace route something else just so you understand what I'm showing. Let's trace route google.com. What this kind of does is it kind of like does a ping, but it checks to see the path that your packets are taking through an IP network all the way, hopefully, to the end. It'll give up after 30 hops. This tells you how many pieces of hardware your data is traveling through, your application layer is traveling through, before it finally hits the server. It's not going to, it doesn't always do DNS lookups. As a matter of fact, when we turn off DNS lookups, or it'll go a lot faster if I don't do that. Excuse me, mine is D. Do not look up names. See if it goes any faster. Yeah, it's not going to try looking up the IP names of those devices, or the DNS names. Sometimes these things don't have DNS names, so you get timeouts. Also, not every piece of equipment on the internet bothers to respond to pings and trace routes. They just ignore you. So your computer has to wait and time out. Okay, so now that I'm on the local network, I can do what I would normally be able to do in the EI lab, which is, if you were following along in the instructions, it says to open a web browser. Actually, it says open Internet Explorer. I'm not going to use Internet Explorer. Instead, I'm going to use what's called IE Tab. So I do want everybody to download and use Google, but then make sure you add to Google something called IE Tab. So just Google for IE Tab, Google Chrome, and that's a special extension. Add that extension to your Google Chrome, and what that does is it basically turns on Internet Explorer compatibility mode. And the only reason we need that is because I'm running some old Citrix remote viewing software which expects to be running in Internet Explorer. So I've already got it running. It sticks a little E up there. See the little Internet Explorer E? I'm going to click on that. Gives me a new address bar which looks like an Internet Explorer address bar. I'm going to type in the URL that I'm told to go to as a student, or that you're told to go to, which is zen.eilab.bauer.uh.edu. This is the screen that you see. This is what I was trying to accomplish. This is the screen that you see when you sit down to any of the workstations back here in the EI lab. We don't have to go through all that VPNing stuff. Your username is going to be your student ID. The password is going to be whatever password I email you later, and you have an opportunity after you log in to change that password. And then the domain, that's one of the other things that you need. Earlier I said you didn't need it for the VPN, but you do need it for that here. The domain is eilab.bauer.uh.edu. That's the domain of what's running here in the EI lab. So type that in, EI lab. And that, the Zen, is the specific name of a server. So let's go ahead and type that in. That's the local Citrix server, which is another type of hypervisor. We're learning that in 4397. In this case, this is the host part of the name, and this is the domain part of the name. Windows does it this way. This is Internet nomenclature. This is Windows nomenclature. They do it like that. The name of a host or server at some domain. But we want to use that kind of nomenclature. Then you click log on. You want Internet to remember? No, I'm going to say no. The first time you run this, it might take a minute or so to finally come up with this little screen with a play button on it. And that's because it's actually going to be getting a new machine out of a virtual catalog and assigning it to you and booting it up. If everybody was doing this at one time, that gets kind of slow. I've booted mine up already so that I know it's operating. I'm going to click that. This will open a new window. Here it is. It's on my other screen here. New pop-up window, and there I am. I'm already logged in actually. So I am now looking at a Windows 7 virtual machine running in the EI lab. Not one of the workstations, but a virtual machine. It has no, it's not real. It has no hardware associated with it. It's all virtual. I always click on this read write access. Doesn't really matter what you click on that. So I'm not using TeamViewer. I'm not using Chrome Remote. I'm using the Zen Citrix Remote Viewer, which can be accessed through Internet Explorer. I downloaded it already. If you go to that zen.eilab page the first time, it'll say, hey, you don't have the Zen desktop. Do you want to install it? Yes or no? You click yes to install it. So if I click on the start button here and I see I'm logged in as this Jake Messenger student, I can go to computer, click properties, and it'll tell me this is a Windows 7 professional machine. again, I'm trying to build some Windows 10 machines for you. I'm student VM number 43. You are the admin of this computer. This is where you're going to be conducting your experiments, installing Wireshark. You can install the advanced IP scanner here. We'll do some other experiments with respect to networking on these workstations, because like I said, not everybody has a workstation that they can install things on. Okay, so everybody got that? There's step-by-step instructions on doing this from the point of going into the EI lab. So there are step-by-step instructions starting from this point right here. Excuse me, not that point. Let me log off. Starting from this point right here, but there are no instructions on how to VPN into the lab. I just figured that out, how to do that last night. 1, 2, 3, 4, 5, 6, 7. Actually, let me go back into it real quick because I want to show you something. Now, I mentioned it might be a problem, by the way. Where it might be a problem is if you have a local area network and your local area network already has a 192.168.1.31 IP address on it, they are going to conflict. They're not going to work. So what you're going to have to end up doing is possibly renumbering your network, or there's other software that you can download that will work. I'll send you instructions on that, but I want to see if anybody has that issue or not. When you're remote viewing under the Zen desktop, let me just show you this real quick because I know it's a question that's going to come up. See that little bar at the top there? I click that and that little bar minimizes itself. Every remote viewing program, I just click no access on that time. Every remote viewing program, regardless of what it is, whether it's TeamViewer or Microsoft remote desktop. Some people have used the Microsoft remote terminal services. This is the one that Microsoft builds in. Anybody ever seen that one before? Or TeamViewer or Chrome Remote or GoToMyPC. There's always going to be some little bar somewhere. It's either going to be at the top here, or on the side, or on the bottom. And they're all a little bit different, but they all generally have the same kind of function. There are certain things that you need to do on a remote computer that you can't do locally. Like, for example, what if you needed to press Control-Alt-Delete to reboot this remote computer? If I were to press Control-Alt-Delete right now on my laptop here, it's going to reboot my laptop, not the remote machine. I may want to copy and paste data from my local machine out here to my remote machine and vice versa. I might want to do screen captures. I might want to change some other parameters. So there's usually, and some are fancier than others. There's the Control-Alt-Delete. I can go to full screen mode if I want. I can disconnect and leave the session running. And you look under preferences and we can see different things. You can actually, the Zen desktop is pretty good. If you have multiple screens on your computer, if you're one of these heavy power users with 2 or 3 screens, you can string the Citrix Zen desktop across all 2 or 3 of those local screens and it'll fit. Or you can do this scale to fit or actual size. I'm going to do scale to fit. If I do scale to fit, by the way, I can do that. Make it really teeny, or I can blow it up. So if you have a very high resolution monitor, you can actually blow up this screen bigger than the resolution actually is on this computer. This computer, for example, this virtual machine, its resolution is probably only, let's see, yeah, it's a weird size. Oh, it's a dynamic size. It's because I'm literally dynamically changing its resolution as I do that. If you want to leave that computer running, here's an issue that, and a thing that's different than most other remote viewing programs. If if you were to click this little down arrow and click, or actually if you were to click here and click log out, don't click shutdown, by the way. If you're ever on a remote session like I'm doing right now, do not ever click shutdown. What happens if you shut down a remote computer? How do you turn it back on? If you can't get to the start button, you can't turn it back on. The only way you can turn on your virtual machine if you shut it down is you gotta email me so that I can log into the virtual environment desktop and go remotely power it on for you. You don't have access to that. So be careful when you're using these. If you do a log off, that it will log you out of the session, but it will also put the computer in hibernation, which is almost like shutting it down. The only difference is the only way you can wake it back up is from this VPN method with the Citrix Zen desktop. If you chose to install Chrome Remote, which is what I recommend you guys do just to learn how to use it, learn how to do it. That's one of the mandatory assignments is install Chrome Remote. That's a part of that first assignment when you're setting up your EI Lab machine, is I have everybody first download Chrome because Chrome won't exist yet. The only thing that's on these Windows 7 virtual machines or Windows 10 virtual machines is either going to be Internet Explorer or that new piece of crap Microsoft came up with called Edge. Anybody used Edge yet? So you won't have Chrome. So you have to go open up Internet Explorer or Edge and go type in google.com. Or you can go Bing it. By the way, for those of you who use Bing or have used Edge, the most Google or the most Binged for, the most searched for string at bing.com is how do I download Chrome or google.com. So go to google.com, download, and it'll probably tell you when you go to google.com, hey, do you want to download the Chrome browser? First of all, if you don't have a Chrome account, sign up for one. Okay, I've already signed up for one. I've got one there, Tick Messenger. Sign up for one. Then download and install the Chrome browser, which is what I've got running here. And then you don't need to use Internet Explorer anymore. As a matter of fact, you can just unpin that from the desktop. I don't think in any cases do we need Internet Explorer or Edge in the case of Windows 10. Once you've got this installed, then you can go install the Chrome Remote Desktop. So I'm going to do that real quick on this machine. Yeah, I can't type today. And I'm going a little bit over on time because I wanted to use the last half of the class to finish up chapter 2. Chrome Remote Desktop. You have two options here. When you start up the Chrome Remote Desktop, you have remote access and remote support. You don't want remote support. Remote support is in the case of where you just want to share your screen for the duration of this session. Kind of like what we're doing right now with, excuse me, with Zoom. You want remote access. Now, I've already set up remote access on a bunch of other computers, so I see them here, but you won't see any of this in the beginning. But you might see this. Now, I've already set up this device at the bottom. If your device is not set up, what you'll see at the bottom here is set up this computer for remote viewing. So you'll click yes, I want to set up this computer for remote viewing. It'll download a piece of software. It'll ask you to enter a PIN. As a matter of fact, I'm going to turn it off. Let me throw this away, turn it off, so that it reverts back to not being able to be remotely viewed. This is what you'll see when you first start up Chrome Remote. How many people in here have ever used Chrome Remote before? Not very many of you, I'm going to guess. So
I just installed in my computer and it has frozen. I have Mac. Yeah, I have a MacBook.
Oh, sorry about that. Well, I can't speak to the. It should work fine on a MacBook. So once you install it on a MacBook, you don't need to do this part on the MacBook, by the way. The only place you need to do this part, setting up remote access, is on the remote workstation, on the thing you want to view. So it's going to say set up remote access. You won't have anything in here yet. Click turn on. It's going to ask you, what do you want to name this computer? It's going to use the computer's name, but you can rename it whatever you want. Stick that in the front just so that I know where that machine is. A lot of you guys are using laptops with, and the names are just random. They're like HP 3723-5 because that's what it was told to be when you first installed Windows or when the technician that built your machine installed it. Enter a PIN number. This doesn't have to be a super hard to remember PIN number because first of all, you cannot get to this and you can't remote view a computer unless you're also signed in on the other computer as your Chrome user, as your Google user. So I usually make my PIN number something like my student ID, or a number that's easy for me to remember. So feel free to use your student ID. Even if I knew your student ID, I can't remote view your computers because I don't know your Google Chrome account. If that little box is checked automatically down there, help improve Chrome, uncheck it. Do not help Chrome do anything. Don't ever help anybody do anything. Any companies. I've mentioned that before. I think it installs extra software in the background that just slows things down. Now click start. It's going to, now I've already downloaded this program, but I don't want to say that. It might actually, down here, it'll show a little program trying to install. Or it might pop up here and it might say, what do you want to do with this program? Do you want to save it or install it or run it? Chrome Remote Host.msi is what it's called. Once it's installed, then you'll get this line at the bottom. And you'll also see it somewhere in your list. This is my list of computers. Why don't I see it? I should see it in this list. They might have fixed that. That's kind of a bug, and they might have fixed it because you should not see it in the list. You can see I've set it up on a lot of older computers in the past that I don't use anymore. So it may not be shown up here, but that's okay. You don't really want to show it up here. At this point, what you want to do is you want to now go to your computer locally. You want to put this aside. I don't want to mess. I don't want that. Log into Chrome Remote Desktop on your local computer. It does not have to be set up for remote viewing. This one is not set up for remote viewing. It's my laptop I'm using here. But you should see somewhere in the list, there it is, EI Lab Student VM43. I can click on that, and I will end up remote viewing this computer over here. Got to put in the PIN number. Now this is going to be kind of freaky. Watch this. Now I'm remote viewing this computer two different ways. I'm remote viewing it from right here, and I can control it right here, or I can control it right here. Kind of freaky, huh? And stuff going on at the same time. Which one's better? I don't know. Chrome Remote, if you don't have the Zen desktop and you want to set this up on other computers, I would recommend using Chrome Remote. In any case, I still want you to set up Chrome Remote. In addition, yes, this video will be uploaded later today on YouTube. I was up till 10:30 last night trying to get the VPN working. So once you've set up the Chrome Remote, then go experiment. If you've got access to other computers that you regularly log into, a work computer, your parents' computer, your friend's computer, whatever other computer. If you have more than one laptop, if you have an Android, I've got Chrome Remote Desktop running on my Android. So check this out. I can run Chrome Remote Desktop here. Here's the list of all the computers on here. So I should be able to see student EI Lab student VM43, there it is. I'm clicking on it now. And in just a minute, it will pop up. Oh, it's asking me for the password, excuse me, the PIN number. It's going to connect me right here. Isn't that cool? Now, it's not too super easy to use. You know, you can move the mouse around with your thumb on the screen, but it is usable. It is useful. If you left something open on your desktop that you needed to close, this has saved me a bunch of times, being able to access a server or a workstation or a virtual machine remotely from my cell phone while I'm sitting on an airplane or when I'm sitting, you know, on a beach in Mexico or whatever. Really neat stuff. The Zen desktop, I'm sure they do have a version that does something like this, but I don't have to be using VPN to do that. So you don't have to do this, but I highly recommend that you do it so that you learn that this is a very valuable tool. That's, again, what I'm trying to teach you guys in this class is best practices and valuable, helpful tools to use. Can you see this in the little window? I'm holding up my phone. Can you guys see my phone? I know I'm very small probably because I'm in the upper right-hand corner. You stop sharing my screen for just a minute and I'll show you. Can you guys see me? You see a picture of me on your screen at the same time as my remote viewing screen? Yes or no? Okay. Just one. Then I'm not gonna stop sharing for right now. Only one remote computer at a time can be viewing that computer. So it kicked me off. If you notice, it kicked me off over here because something else started viewing it. So now I'm going to kick my cell phone off by reestablishing connection. And if I want to, I can tell it, remember that PIN number, so I don't have to keep typing it in every time. And now I'm remotely viewing my Zen workstation again. Jake Messenger student. Pretty cool, huh? Now, this is what I wanted to show you earlier. When you're using Google Chrome Remote or TeamViewer or whatever else you decide to use, and if you want to, go ahead and install TeamViewer. Install Splashtop, experiment. There is literally 2 or 3 dozen of these remote viewing programs out there. There's VNC, type VNC. Don't install a dozen, you'll make your computer run very slowly, but experiment around with 2 or 3 of them. TeamViewer, another very popular one, and try those. But my point is the little black bar that we're seeing here in the Zen desktop, make sure that you do not log off if you're using something other than the Zen desktop, because if you do, it will hibernate that computer. So what you want to do is simply close. In this case, I'm just going to close that Chrome window. It leaves the computer running. So here, your virtual machine is still running, even though I closed it. I'm going to close this. It's going to say pressing disconnect will close this window, but will leave your virtual desktop running. Do you want to do that? And I'm telling you, yes, you want to do that. It's not efficient to do that. In a corporate world, they're going to tell you, no, don't do that. I want that machine to go away, to hibernate. And that's because you're using a shared environment. And if everybody leaves it on, leaves their computers on, it's using up resources. But we've got plenty of resources, so don't worry about that. Disconnect. It's still running. It's just running in the ether. Not to be confused with the Ethernet, but it's running in virtual reality. It's like the Matrix, okay? You're now back in the real world, and everybody's still in the Matrix. You guys, everybody watch the movie The Matrix, or Matrix Reloaded, Matrix Revolution, all that? If you've never watched The Matrix, go watch it. Pretty neat movie. All right, so now let's finish up the rest of chapter 2. Not a whole lot more to it, but there are some important concepts. Did you guys think this was interesting, the remote viewing stuff? Or at the very least, can you see the power of it? About being able to remote view computers. Now, like I said, that remote access thing, remote support thing, if your grandma or your friend or somebody is having a problem, I can't use my computer, you know how parents and grandparents are. I lost my email. I've got a friend of mine, he's 81 years old. He uses computers all the time, but he's 81 years old. And he'll call me on his cell phone and say, like, everything on my screen is upside down now, because I don't know if you knew this, but there's a key combination in Windows you can press and it'll flip everything upside down or to the left or to the right. I'm not going to tell you what it is because I don't want people to accidentally do it and then not be able to flip it back, but it's something along the lines of control up arrow, control down arrow. Yeah, exactly. It's a great prank for work, Soraya. I used to do it to some of the profs here when they first added that into Windows 7, and man, that pissed off a couple of profs. Yeah, not cool, exactly. Unless like I'm a tech guy, so I knew that, but man, did I piss off a couple people. I figured they'd be smart and whip out their phone and Google how to flip it back over, but no, they made a call to the support desk and made a big deal out of it. So anyway, if you want to play a prank on your roommate or your brother, do that. I don't know if you can do that in a Mac, but I'll bet you can. Something similar. Back to my downloads folder, which I need to clean out because there's so much stuff in it, but I'm sure I still have chapter 2 in here somewhere. If I don't, I'll just download it again. Okay, so chapter 2 was I thought we were going to get to the physical layer, but I thought it was important to show you all of that remote viewing and VPN stuff. And talk a little bit about, we've mentioned several items, talk a little bit about these programs or these apps, ipconfig, ping, and what am I missing from here? Route, uppercase print, by the way. These 3 commands right here, which are built into Windows or added to the kernel of Windows, very useful. Oops, I got rid of ipconfig. Very useful commands for network managers. So start using those from your command line. Oh, and what's the other one? There's one more, trace RT. Now, the actual command, by the way, is trace ROUTE, but that's Microsoft abbreviated it for whatever dumbass reason. The real command in the real Unix world is trace route. That's what it stands for. In ipconfig, the correct command name is actually ifconfig. The only reason I'm mentioning that is because I think, I'm not positive, but you Mac people can back me up on this. I think in the Mac world, it is ifconfig. And I think it's also trace route. You can tell me, somebody try that. Tell me if I'm wrong or not. Go open up your terminal and type in trace route and then type in trace RT and see if either one of them work, and then just let us know in the chat. Okay, we were talking about application architecture. Boom, 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 boom. We talked about this. This is a very good matrix, by the way, to also memorize, hint, for the test. This helps you understand what these terms mean. And these IaaS, PaaS, and especially SaaS, software as a service, these are big marketing terms that Microsoft and Amazon and Oracle, they like to throw at you. Okay. Again, if you put these terms on a resume, oh, I've studied SaaS, your hiring managers will go gaga over that. Oh my God, you know all that? That's cool. We're going. Again, you need to know what the hell you're talking about. Don't just stick it on a resume and go, oh yeah, I know VPN, without knowing it. That's the whole point of being in this class. But make sure you understand what this matrix is trying to tell you here. The criteria for choosing a particular, and I talked about this, but let's just go over it really quickly again. The criteria for choosing which architecture you're going to decide upon is dependent upon these elements, cost. And this is the primary deciding factor right there, is cost. The number of clients that you need to support and the type of clients that you need to support. Now, in some cases, software as a service is just not going to work for some of your employees. For example, your engineers that are using AutoCAD programs, CAD design programs, or if you're in the entertainment industry and you're using video editing software, that just doesn't work very well as software as a service. And the circuits, what kind of circuits do you have that connect your business to the outside world? If everything lives in the outside world, your circuits might be too slow to handle all of the throughput necessary to bring all the data down and bring whatever down you need to bring down. Consider development costs. So consider the infrastructure that you already have versus what you don't have. And like I said, most companies that don't have any infrastructure at all, that don't want to buy any infrastructure, and don't know where they're going to be 6 months from now. You know, we might go out of business, we might be 10,000 customers or employees, we don't know. Let's just go SaaS right now because it's renting. Just like renting a car versus buying a car, renting an apartment versus buying a house. I don't know where I'm going to be living in 6 months, so I'm just going to rent a house or rent an apartment for right now. And then scalability, how scalable do you want to be? How flexible do you need to go up and down in terms of employees and services? Okay, here's what happens, and this is true for most, this general concept of going back and forth with a request and a response is true for most application layer programs, including email, instant messaging, gaming. In the case of HTTP, a request is made. That request goes over the internet, www.uh.edu, for example. And we're talking about layer 5, okay? We're involving any of the other layers right now. Yes, it's going through all the way down a physical layer, back up to the application layer of the server, but we're just looking at the scope of layer 5 right now. The server gets that request. If it was asking for a specific file, it will look up that file and return it. Most of the time when you go into a new website, you don't know the name of the file, or you don't know any of the input stuff that goes after the domain name. So it gives you a beginning file like index.html or index.php. That's the kind of standard first page that you get. So they're going to create a generic page, send it back to you. The request and response have two pieces to them. There is a header. Well, first of all, there's a request line, there's a header, and then there's a body, potentially. Just like in an email, there's a heading of an email, and there's a body. In the case of an HTTP request header, it tells us the date. So let's say I'm sending a request to uh.edu. This date here is the date that my computer thinks it is, not the server date, not an international date. That's important. You're shrinking, Franklin. You getting tired? Tilt your camera down. That's okay. You can slouch. I don't care. So that's your time and your date. Why do you think that's important? Why does a server need to know what your date and time are if you're not in the same time zone? Why is that important? Why do we care? No thought?
For the packets moving back and forth so it can line up?
Nope, has nothing to do. We don't care about, all we're talking about is application layer. Think about it in terms of up here in your mind or in the real world, why would somebody else need to know what time it is where I am? In case I need to give you context sensitive information. Like if you ask me, like let's say I'm a website that tells people the time and you say, what time is it? If that web server is in New York and you're in LA, you don't want it to give you the New York time, you want it to give you the LA time. That's probably not the best example because usually your computers can look up the time, but it's important for the server, if it's in another country or another time zone, to know what your time is so that it gives you correct context sensitive information. like shows a picture of a sun on the screen instead of the moon, as an example. It also tells the server, it will tell the server what the user agent is. The user agent is the actual name of the browser that you're using. In this example, this is Mozilla. What is Mozilla, by the way? Has anybody ever heard of Mozilla? Mozilla. Let's just type in Mozilla. Mozilla is Firefox. That's right. So where do you think that term, and if you know this, then you're probably going to get an A in this class. I don't have to guarantee an instant A. Mozilla. Does anybody know where that term came from? Why Firefox calls their browser Mozilla? Because it came from the original browser. What was the original browser that was developed? Mosaic. By a company called Spyglass. Let's see, Spyglass Mosaic. First browser. Mosaic web browser was the first web browser. I remember using the very first web browser in 1990. There wasn't much to it, but you could make web pages that had pretty pictures in them. Mozilla, basically, Firefox, the company, took the original source code for Spyglass Mosaic and said, let's make this a much better program. In other words, let's make this a big monster program that can do all kinds of stuff. What's the most famous monster in the world? What's the biggest monster in the world?
Godzilla.
Godzilla. That's right. So they said, let's call it Mozilla. Kind of cute, isn't it? Okay, so Godzilla, Mozilla, that's where I get it. There are several apps that stick the word Zilla on the end, like there's FileZilla, TransferZilla. There's probably an online car selling website called CarZilla. I have no idea. So anyway, that's where that term came from. Internet Explorer has their own little name, but Google is, I forgot what Google says, but you can look at these things if you want. But, and then the refer is the actual URL that you typed in, because sometimes this gets modified when it goes over to the server because it sends a different information back. Like, for example, when you go to your bank, like chase.com, I type in chase.com. Well, there's not just one server in the world that's chase.com. It actually goes through a proxy, and then you get assigned to a particular subserver. So you might be talking to chase03b.com. at the time, not chase.com. So that gets modified, but that server needs to know what you originally typed in order to route you properly. And then there's different methods of actually getting the data. There's a get and a put method. This will make more sense in a minute. This information you don't normally see. The information that you do see is in the body of the email. So when you get a response back, the first thing that you get back is the version of the web server that's running, not the web browser, but the web server. This is a very old version, HTTP 1.1. You get a special code back. That 200 means, yes, you found a good website and I've got a page for you. And the status is, okay, here comes your data. How many people have ever gone to a website before and your computer responds with a 404 error? 404, you see 404 on the screen. That means you tried to go to a website and you typed in a name of a file after the domain name, and that file doesn't exist on that server. The server generates what's called a 404 error. Now, normally, most companies, they customize that page so it doesn't look stupid. It doesn't go 404 error. It says, we're sorry, we can't find the page you were trying to look for. Please try something else or click here. But 404 means you tried to get a file that didn't exist. I'm not going to ask you to memorize those codes, but there's about 10 different completion codes. Here comes a header back from the server, which tells you, if you wanted to look this up, what the server program is. In this case, it's Apache, which is true in about 85% of the cases in the world, if not more. the dominant network server program in the world is Apache. Now, remember how I talked about Mozilla getting their name? The way Apache got their name is their code was originally based on the original network server code, also put out by Spyglass. And in order to make it work better, they had to apply a bunch of programming patches to it. A programming patch is just adding additional code into this existing source code. And so that's where they get the term Apache. We're applying more patches all the time. It has nothing to do with the Native American Indian tribe. It's not named after an Apache helicopter. It's named after, literally, I'm putting patches in this code. So it's kind of silly how we get a lot of these different names in the networking world, but that's where that comes from. Now, this response body might be HTML. It might be a JPEG file with bitmap data in it. It could be a bunch of garbage that you can't read. What determines what this is and how it should be interpreted by your computer depends on the header here and what is in context type. The most common context type is text/HTML. If you were downloading a file or a video or a picture, it might say content type is JPEG or PNG or something different. That's important because if you don't tell the browser what the context type is, you might just get a bunch of that rather than an actual web page. How many people have ever gone to a website and rather than seeing a normal looking website, you see a bunch of HTML hypertext code or a bunch of XML code? That's because the programmer forgot to properly identify the content type of the data that they're sending you. They left off the header, in other words.
Excuse me, sir, quick question.
Yeah.
Is there any way, or is there a way to view that information that you just?
Yes, you can do that actually in a web browser. If you're looking at a web page, let's see if I can show you that real quick. And it depends on the browser that you're using, but let's say here's a web page here, okay? There's usually a way to go view. Let's see if I can find it here. Under, I can't remember where it is, and let's just go Google for this. We want to view the page source. How to view page source. Navigate to view, developer view source. Okay, where's view?
Well, I think if you click on the web page and if you go to the web page and just right click, you'll be able to see it.
Totally right. View page source or control you. Thanks for reminding me that. That's what you're getting there. We don't see the header, but we see the page source there. So it's mostly a bunch of code. This is what hackers do. They view page source and they go through and they look for the hidden VB script and things like that. Okay, let me see if I can finish real quick. I want to definitely finish with this chapter. So I'm going to go really quick through these last few frames, okay? So I want to finish by today. Email. Now, the World Wide Web, not been around actually that long, only since about 1990. And that's because everything was text-based before that. But email has been around for a long, long time, since the 60s, okay? It wasn't, our email addresses weren't jake@uh.edu. They were x2345@192.168.something.something. We didn't have domain names. Here's some different program types. You have what's called a mail transfer agent and a mail user agent. A mail transfer agent is the server piece of software. Every server that sends and receives email is running mail transfer agent software or applications, something like SendMail or Postfix. You, as an end user, are using a mail user agent, either Outlook or maybe Apple Mail, or maybe if you're smart, you're using Thunderbird or you're using Gmail. You're using a web GUI agent. SMTP is the most common mail transfer protocol. It's used specifically to send and receive mail, sending mail from you to a server or sending mail from one server to another server. Those are called mail transfer agent protocols. Mail user agent protocols, what you use to receive mail to your Outlook or your Thunderbird or your Apple Mail, if anybody uses the Apple Mail program, is you're probably using IMAP or POP. Probably nobody's using POP anymore. POP is not a very popular web email protocol anymore, and that's mostly because with POP email, all the email got downloaded off the server, put on your local computer, and it was deleted off the server. Well, these days, everybody lives on multiple computers. So if you downloaded all your email onto a laptop and then you needed to read that email somewhere else from a different computer, you can't because it's living on that laptop. So most people are using IMAP, which is it downloads only the headers of the email, what's on the outside of the envelopes basically, and then optionally you click on something and it downloads a copy of the body of that one email. It doesn't download and erase all the email on the server. So IMAP, much more popular. Let's not worry about ASCII for now. Here's how email works. It is opposed to, it is a little bit different than a client-server web interaction. Your web interactions are pseudo-conversational. Your email interactions are not, because it's presumed that the person you want to send an email to, they may not even have their computer on. So it works just like the regular post office. You don't drop a letter directly into the mailbox of the guy that you want to send a letter to. You drop it in your mailbox. Then a postal carrier picks up that email, sends it through his network, aka a LAN here, goes to the local post office, in other words, your mail server. So everybody's using a mail server of the provider that they're connected to, either Comcast or AT&T or Google or U of H. The email gets uploaded there, then your designated email server will periodically try to contact the email server of the recipient, whoever's in the to field. And all this information is public. It's publicly published by domain registrars. Periodically tries to send that mail to the recipient server, and then at some point, the recipient of the email, another client, turns on his laptop or opens up his email program, and it downloads that copy of that email to the computer, leaves a copy of it here on the server. Once an email is sent from a server to another server, it's deleted off this server, but it does still live on the recipient's mail server until you specifically delete it, or until a certain amount of time passes. Yahoo, by the way, I hadn't used my Yahoo email in a long time. Anybody still use Yahoo for email? I had Prof Jake at yahoo.com. I had probably 12,000 emails in there because I didn't check my email that often, but Yahoo started deleting email. So if you haven't checked your email box in more than 1 year, all of your email will be gone. Your email address will still be there, but your email will be gone. So I lost a bunch of email. I don't know if it was important email or not, probably not. But yeah, I had like 12,000 emails and now I have like 10 because I haven't logged in so long. And that's because I stopped using Yahoo and I use Gmail. Why do I use Gmail? For the same reason that people don't use MySpace anymore, use Facebook. Anyway, so email, it's a two-tiered thick client kind of a situation because you have to have an email program on your computer, goes to a server, that server communicates with another server in the world, and the recipient computer receives that email. Your email program has to speak at least two protocols. It has to speak SMTP to send mail up to a server, and then it has to speak either IMAP or POP, or there's a couple of others to receive email down from the local server. So, email has header and body just like HTTP does, excuse me. HTML is a presentation language. There's a header and a body. It's simpler to understand because in a header is things like from, to, the date, and the subject, and a few other things that you don't see, but that's generally what you see in the header. And in the body is going to contain basically the body of your message. It may have attachments on it, but most of them are just text. Now, email, like I said, has been around much, much longer because it was just text-based back in the beginning. It wasn't graphical-based, and it's still not really graphical-based. You can send pictures and video and email, but they're basically sectional attachments. You have a main body, but then you have attachments that get stuck on the end of the email, basically, that are then possibly embedded in the body, but usually they're separate attachments. I'm not going to ask you to know what's inside an SMTP packet. Just understand the elements are similar. The from and the to, the date. What you don't see is the user agent or the server agent. That's not important in email. Don't worry about that. Here's some other application layer protocols which you will be using throughout the semester. File Transfer Protocol, or FTP. The main reason why the internet exists is so that we can transfer files and thoughts back and forth, email and files. The web thing didn't come, the hypertext and web pages didn't come till much, much later. That concept, like I said, didn't come around till the 1990s. Telnet or SSH, so that you can get basically a remote command line to another computer. IRC, Internet Relay Chat. I don't know if anybody has ever heard of IRC. It still exists. It's anonymous chat rooms. You can run an IRC server. I used to run a very popular IRC server here at U of H for game players until U of H said, you need to shut that down. And that's because we found out that my IRC server that was sitting in my lab here was accounting for 12% of the traffic between Europe and the United States. 12% of the total internet traffic. This was back in the mid-90s, and I said, you need to shut that down. You're using up the bandwidth of the USA, and we can't communicate with the UK. So it was pretty amazing to me. XMPP is what we use for video and voice. We're using XMPP right now to communicate with each other, and then we have other protocols like DNS, DHCP, things that kind of don't fall into the application layer. Let's skip instant messaging. Who cares about instant messaging? Video conferencing using XMPP. We're all using video conferencing these days. What's the reason why we use video conferencing? Because we can't meet each other face-to-face, or it's dangerous to meet each other face-to-face, or we're not allowed to. Basically, I should say. Video conferencing, by the way, has been around for a long, long time, for 30 years or more. In fact, if you watch the movie 2001: A Space Odyssey, has anybody ever heard that movie before? It's an old movie. It's actually based on a book. It's based on a book by one of my favorite authors, Arthur C. Clarke. He was actually a futurist, not necessarily an author. It's kind of like L. Ron Hubbard. He wrote a book called 2001: A Space Odyssey, which Stanley Kubrick turned into a movie in 1968. This is an old movie. But if you watch this movie, anybody ever heard of it, by the way? 2001: A Space Odyssey? It's one of my favorite movies. It's over 3 hours long. So it is a long Stanley Kubrick style movie. If anybody's ever seen a Stanley Kubrick movie, like that one that Tom Cruise and Nicole Kidman were in, they kind of drag a little bit. And Stanley Kubrick's just batshit crazy weird. He's dead now, but he was weird when he was alive. The movie gets a little weird, but the point is that they're using video conference telephones in there, and a lot of the things that hadn't been invented yet, he foretold the future of. He foretold the future of cell phones. He said, one day you're going to have a device in your pocket, which is going to be a communication device, but it'll be much more than that. You'll be able to order food off of it and check the weather on it, and it'll be about this big. He invented the concept of a cell phone 30 years before it existed. Your dad's trying to force you to watch it. Laura, I have to tell you, it would benefit you for this class and just to be a better all-around human. Watch the movie. Sit through the 3 hours. Go. It's on Netflix. It's on Amazon. You could probably just download not download, but stream the whole freaking thing. What is Musk influencer? What the heck is that? Anyway, let me finish this up real quick. We're almost done. So implications for management as far as the application layer is concerned. The primary purpose of a network is to provide an environment for applications. That's an environment for you. That's the only reason the network exists, is so that we can connect applications together over distance, aka telecommunications. Okay? Now, there's many more applications than there has ever been before, and there's going to be many new applications and new communication protocols and things that we haven't thought of before. Like we can transmit almost all of the senses, or the important senses, across the internet: sight, sound, but we can't tell what something tastes like, or we can't tell what something smells like over the internet. We can't really feel things over the internet. But those are the kind of things. Oh, okay, I'll have to watch that movie. Elon Musk, he probably was a big fan of Arthur C. Clarke too. So those kinds of things are coming. Eventually our society will end up being something where humans don't personally interact with each other. It'll be kind of sad, but that's what we're going to evolve into. Humans won't move around much. We're going to get fatter, and our arms and legs are going to shrink. I'm talking about thousands of years. Don't worry about your kids. Thousands of years from now, we're going to be funnier looking than we are now, because we don't need these corporeal bodies as we have now. In fact, there's another book that Arthur C. Clarke wrote if you want to read 2001 Space Odyssey, that's great, but it's a big, thick ass book, like 1,200 pages long. He wrote another book, which is smaller, which is more awesome, called The Light of Other Days. And it talks about the internet getting smaller, the devices getting smaller and smaller and smaller and smaller. So finally, the cell phone ends up being implanted in your head. And then pretty soon they figure out how to write apps that will rewire your brain. So the apps are running in your brain, in your gray matter. And that's supposedly unused gray matter. So you don't even need hardware. It's running in your brain. So people don't need to go anywhere. People can communicate with everybody else. In other words, there's true, what do they call it? Not telekinesis, but telepathy. You're telepathic. Everybody can talk to everybody else in the world. But the book talks about the social implications of that, because nobody any longer can keep secrets. Everybody knows what everybody else is thinking. That'd be pretty freaking scary, wouldn't it? If everybody knew what I was thinking right now, well, maybe I shouldn't say, but if everybody knew what everybody else was thinking right now, you might not want to talk to that person ever again. There's certain things we don't share. Okay, that's it for that chapter 2. We'll start on chapter 3 in the next class. So don't do that homework, or you can do part of that homework now. You can attempt to get a VPN connection to the EI lab with the information I've given you here. However, I have not yet set up the, scroll back up here. I've not yet set up the virtual machines. All I've got is Windows 7 virtual machines. And like I said, I'd rather that you guys use Windows 10 virtual machines. It's been requested of me before. It's about time. We just need to get off 7 and go to 10. But it's kind of all up to me. I don't get any support from the RICS lab. They want me to do it all. So what's the IP address? It's 192.138.194.45. It's right there. That's the IP address of the VPN server you're going to try to attach to. The pre-shared key, also known as the PSK, that's really the only password you need for right now. You don't even need your student ID and domain. Just to see if it will establish the VPN connection is that. Okay, you're gonna set up an L2TP tunnel. Okay. I'll post this video so you can watch the video. And what else you want to know? Once you've done that, if you're successful, try pinging 192.168.1.31 from a command line. If you can ping it, congratulations. If you can't, that means that either the VPN was not set up properly, or you already have 192.168.1s on your local network, which will cause a conflict. So I want everybody that has that kind of conflict, would you please email me and let me know, and I'll try to contact you, and we'll use you as an experiment. We'll see what we need to do, because like I said, if you've already got 192.168.1 at home, that one dot stuff, and I've got 192.168.1 dot something here, how do we blend those together properly? Okay, so I'll see you guys on, let's see, it's Thursday. I'm not going to have an official class tomorrow. If I have time, I will do a Zoom meeting. I'll go ahead and turn on Zoom at 2 o'clock, and anybody that happens to log in, we'll talk a little bit. We'll experiment around with doing the VPN. But for right now, your homework is see if you can try the VPN and look up those terms we talked about today. Watch the videos for the previous classes if you've missed the previous classes. And I'll see you guys on Monday, and I'll walk you through setting up your Windows 10 machine on Monday. Have a good weekend.